How would it be in feet?
In feet, that's like 39 inches, I think, roughly. All right, we'll go over conversions in a minute. See, here's one reason we failed in this country to use the metric system. We focused on converting metric to standard. That's ridiculous. Just start measuring in metric. Forget about standard. The conversions are the stupid part. Do we sometimes need to convert because something was stated a certain way? Yes. Should we measure in metric instead of standard? Yes. That simplifies the whole problem. So kids are growing up these days having measured in both metric and standard because they're both all over the place. And we're kind of in this quagmire of mud that we seem to never be able to get out of. And someday we might.
If we're the only country that, one of the few that use it, and everybody else is using metric,
Yeah.
if we just started using metric, eventually.
Yeah, so
What about all the,
but there's still too many inches and feet in schools. And too many teachers that are still stuck on using inches and feet. Even though every ruler you get for the classroom has both inches and centimeters, people default to the inch one because that's habit.
so it's all the adults who were raised on inches and feet don't be able to comprehend this?
Not that they comprehend it, it's just that we go for the easiest path, and the easiest path is often what we're familiar with. And so most people are familiar with inches and feet, and so when they have to measure something, they stick with that. But if we would just make a conscious effort to not measure with those anymore, I think we'd make a big difference. So let's just go over some things about the metric system. It's important to know what certain things are. Like you all have a good idea what an inch is, right? So if I show you a book, you could tell me whether this book is 2 inches wide or 10 inches wide or something in between, right? Would you be able to tell me exactly how many inches wide it is just by looking? No, right? But you can tell me about, just because you're used to thinking about an inch. So one thing that can help is identify something on you that is about a meter, that is about a centimeter. So let's see, my measuring stick is missing.
It's in the other room with
Oh, it was in the other room.
the blue star.
Okay. All right, so everybody stand up and come over here. Let's find something on you that is close to a meter. So like me, my belt is pretty darn close to a meter, okay? Hold it up to your leg, put it up to your arm. Find something that you can say, oh, that's pretty close to a meter. Like maybe if you put your arm out and say from your fingertip to your nose, that's a meter.
From here to here, or somebody, yeah.
Yeah, so try to, so think about where, your the middle of your waist looks like a meter for you. Hold out your arm. Check that out. So let's see if we come across. So it looks like from your fingertip to the outside of your other shoulder is about a meter, right? Other things you could do, you could like, think about your head down to the middle of my pockets.
So that means from my waist to the top of my head, probably about a meter or more.
Usually
that's-
No, that's not necessarily a halfway point on a person. Everyone's torso and legs are different, but there are some common measurements. So let's say it's a little high, right there. Meter would be right there on you in your head. Right. Did you try your arm? Let's hold out your arm, fingertip. So yeah, pretty similar to the edge of your shoulder is a meter. So it's just nice to know things like that. Other things, you know what a centimeter is? So like on me, here's the centimeter. If I hold up my pinky nail, the width of my pinky nail is almost exactly a centimeter. Check yourself out. Find something that's about a centimeter wide. Okay. So pass the ruler around, find something that measures that amount.
A little tough on Greg.
Everything's too big. Yeah, so maybe you know something that's 2 meters. Like maybe your thumb is 2 meters
That's
wide.
about 2 centimeters.
Yeah, your whole pinky is almost 2 centimeters. Yeah,
Fingernails, well,
fingernail's
almost.
a little over a
A
centimeter.
little over.
Yeah, so you know roughly.
Roughly, yeah.
Did you try? Are there any fingers or fingernails that are about a centimeter or 2 centimeters wide? So just to get a feel for what, because we all have a rough idea what an inch is. We need to have a rough idea what a centimeter is. We need to have a rough idea what a meter is. So if you do a measurement and somebody says, hey, Gary, I just measured you with this tape measure and you're 74 centimeters tall. Well, you know, it's 100 centimeters to my belt, so I think you made a mistake. So I'm 174 centimeters tall, right? You missed that one.
A meter has 100 centimeters.
Centimeters, yeah. So I'm just going to go over this chart in a couple of different ways. So I'm going to use 2 meters for an example. I am under 2 meters tall. Right? If I go from my belt up, there's more room up there.
30, approximately.
So there's about
Up to the
30, 25, yeah, somewhere in there. Maybe I'm 170 centimeters tall, somewhere in there. So a decimeter is smaller than a meter, right? Because it's 1/10. So I need more of them to make the same measurement. The difference is 1/10 when I take the ratio, and so I would need 20 decimeters to measure a meter. And when I write the chart in this way, from big to small, what you imagine is the decimal point was, color, red. The decimal point was here, and I just moved it over one place. Why did I move it over one place? Because I just moved one place on the metric system units. So writing the chart in this order, from big to small units, can help convert within the metric system until somebody gets used to it. This chart and say, oh, something measured 2 meters. If I want to turn it into kilometers or kilometers, however you want to pronounce it, I would have to move the decimal 1, 2, 3 places to the left. So I would have 0.002 kilometers. So these are all ways to represent the same unit. I could do it in centimeters. Move that decimal one more time, and I'm going to end up with 200 centimeters. So this is one way to approach getting used to the metric system. 2 meters is the same length as 20 decimeters, which is the same length as 200 centimeters, which is the same length as 2/1000ths of a kilometer. They're all exactly the same measurement. Just like I can say 24 inches is 2 feet. Here, all I have to worry about, since everything moves by power of 10, is shifting the decimal point. Way easier, Kevin.
So the numbers indicate how many decimal points?
Writing the chart in this order tells you how to move the decimal point to get from any one unit to any other unit.
So if you have meters and you want to convert.
So here I'm saying I'm starting with 2 meters. If I want to shift on this chart 1 unit to the right, that would put me in decimeters, which means I also have to move the decimal point 1 to the right. So 20 decimeters is the same as 2 meters. The blue numbers are a slightly different way of thinking about it. The blue numbers say that a decimeter is 1/10 of a meter. So with the blue numbers, I was focusing on what a meter was. A centimeter is 1/100th of a meter. So there's 2 different ways to think about it. So I'm going to separate them out so we can bridge the confusion. Let's see. I'm just going
So if you multiply that 2 times 1/100th to find centimeter, that's how you move the decimal. That's the multiple.
So first way to think about this table is just how does everything work with respect to the middle value, the middle measurement, I mean, our base unit. And the blue chart here says a decameter is 10 meters. A centimeter is 100th of a meter. So that's like the definition of what each one is. But we can use this chart in a different way. So I'll put that on another page. So the book has this in it, so you should take a look at that later. I'm just going to rewrite this. Kilo, hecto, deca, whatever the base unit is. I was using meters, and then deci, centi. So I can also use these headings as a conversion chart. So here I'm just going to focus on a different number than earlier. What if I focused on 1 meter, for example? If I want to move it one place to the right on the chart, I have to move the decimal along with it, which means the same measurement would be 10 decimeters. If I wanted to move decimeters one place to the right on the chart, I also have to move the decimal, so it would be 100 centimeters. If I wanted to go the other way and change a meter to a decameter, I'd have to move the decimal to the left, following the chart. So that would be 0.1 decameter. I think the abbreviation is DK. I could use that one. It slips from my mind often. DAM, I'm sorry. Suppose we started with a different measurement. Like somebody said they had a measurement of 1 kilometer. How many hectometers would that be? Well, if you move it once to the right, you have to move the decimal with it. It would have to be 10 hectometers. If we moved it again one place to the right, or if you considered we wanted to change kilometers over to decameters, then that would have to be move the decimal twice too, which means you need to fill in 2 zeros. So knowing the order of these base units, or these prefixes in the base unit, can give you a way to convert if you're not used to the metric system. The alternative that's usually taught, instead of memorizing all 6 of these plus the base unit in the middle, is to just have certain facts memorized. So common things people memorize are conversion factors. And conversion factors are very powerful. It's not factors. They are very powerful, but I think this is one place we failed in this country in moving to the metric system by focusing on conversions instead of just measuring stuff. I'm oversimplifying the problem, but I think that's a big part of the problem. So conversion factors would be things like, you guys know there are 12 inches in 1 foot, right? You can use that to figure out whether you multiply or divide by 12 when you're trying to change from feet to inches or inches to feet. Similarly, we could do something like that with the metric system by knowing that there are, say, 100 centimeters in 1 meter. Or knowing that there are 1,000 meters in 1 kilometer. So knowing facts like that is an alternative to knowing that chart. And centimeters, centiliters, kiloliters, liters, those are common, the most common prefixes that you'll see. Milli comes up a lot in terms of milliliters. Millimeters, depending on what kind of stuff you're working with, that's a pretty tiny measurement. So how do we use conversion factors? To use a conversion factor, the If somebody gave me a measurement, like they threw something and it ended up going 7 meters per second. And I wanted to say convert that to kilometers per hour. So we looked at stuff like this way back in Math 212 when we were talking about fractions and taking number or relationships like this and rewriting them as fractions. If I wanted to get rid of meters, I could multiply by a fraction with meters in the denominator to cancel, in which case I would have to put kilometers in the top. And then I'd have to remember, how are meters and kilometers related? Well, according to this fact above, there are 1,000 meters in 1 kilometer. So that tells me in this case I should divide by 1,000 to make the conversion. So just this part of it tells me that I have 7 over 1,000, which would be 0.007 kilometers per second, because the meters divide out. Remember doing that in Math 212 a little bit? You've probably seen it in the other classes. You can also string conversion factors along. So I'm going to do a slightly different version of this in a sec. And then we'll look at the problem Greg had online with the, what was it? Speed of sound. So I want to change 7 meters per second into kilometers per hour. So to do that, I'm going to have to set up some conversion factors, and I want to write this as a fraction, not a per second thing. So I would say 7 meters per 1 second. And the order in which we attack this, it turns out it doesn't matter. So I'm going to do what I did earlier. I'm going to say, well, let's get rid of meters first and convert to kilometers. And the trick is the unit you're trying to get rid of has to go in the opposite position. And so that means there'd be 1,000 meters in 1 kilometer. So that's going to help me get rid of meters. Next, I can attack seconds. Now, some people know how many seconds are in an hour and some people don't. So most people do some intermediate thing, like say, well, I want to get rid of seconds, and what I can think of is minutes next. And so I know that there's 60 seconds in 1 minute. So now I've gotten rid of seconds. Am I at my goal yet, though? Yeah, so I can keep tacking on fractions. So I have 2 choices. I can do 1 fraction at a time, multiply or divide, and then attack with another fraction. Or I can just write them all down. So next, I would get rid of minutes, because that's not what I want. Where would minutes have to go in the next fraction? Yeah, it's got to go on the top. And minutes, hopefully we remember, is a relationship with hours, and that there are 60 minutes in an hour. And so what this tells me is the only thing I haven't crossed out now is kilometers per hour. Kilometers in the top, hours in the bottom. And all of these ones here and here and here are insignificant, because multiplying and dividing by 1 is lame, nothing happens. So all I have to do is decide from the 7, I need to divide by 1,000. I need to multiply by 60, and then I need to multiply by another 60. So just in my calculator, I can take what is 7 divided by 1,000 times 60 times 60, and there's the answer. So I'm going to ask Google. There's a calculator. Anybody wants to check on me, make sure I get it right. Greatly appreciated. So 7 over 1,000 times 60 times 60. That means it would be about 25.2 kilometers per hour. So this comes out to be 25.2 kilometers per hour. Now, how many of you are used to speed in kilometers per hour? Like when I visit Canada and I see all the kilometer per hour signs, it confuses me. So I have to look, and my car, fortunately, has both kilometers per hour and miles per hour on it, so I can keep track of it. But if it didn't, then I have a problem. So could we change that to miles per hour? Well, to do that, I would have to know how many kilometers are in a mile. Anybody happen to know that? So I'll look this up in a second, but I have a recollection that there's about 1.6-ish kilometers in every mile. So a mile is longer than a kilometer because I need more kilometers to keep track of a mile. So I could just ask Google that, and it'll tell me. They will tell me. So kilometers in a mile, and 1.60934, and depending on how you attack it, there's slight variations on that. Remember, a kilometer is 1,000 meters. So that must mean there's about 1,609 meters in a mile. Kind of interesting to know. So I could use 1.6, I could use 1.61, 1.609, depending on how accurate I want to be. I'm going to go with the 1.6. So what would I do with this fact to adjust the 25.2 kilometers per hour? Let's see, kilometers has to go away, right? So that's going to be the 1.6, and 1 mile goes to the top. So it tells me in this case I want to divide by 1.6 to switch from kilometers to miles. How many 1.6s are in 25.2? That'll tell me how many miles are in there. So I can check with my calculator again. The Google calculator. 5.2 over 1.6-ish, 15.75-ish.
So, everything.
Yeah, and again, we don't have an exact measurement, we have an approximate conversion factor. Depends on how detailed you want to get. Am I going to be off by a meter or so? Yeah, but you know, I'm going to total on somewhere. So, not for 8.75. 15? 15.75. So 15.75 miles per hour. I know what that feels like on my bicycle. I know what that feels like on my car. So now I have a better feel for what it means to throw something at 7 meters per second. It's not that fast. Baseballs can fly like 60 to 90 miles per hour depending on the pitcher. So this wouldn't hurt too bad if I get hit with something thrown at 7 meters per second. So it's just a matter of the common way to do it is the way I've illustrated here, where we get some equality between two measurements, and then we use that equality to set up a fraction, and then we use the conversion fractions to get wherever we want to be. And we can do those conversions one fraction at a time, or we can string them along and do a whole bunch at once. Okay? Divide, now multiply, now multiply. There's a couple ways to do that. I go back and forth. I think it's more beneficial to learn this flow of names for certain grade levels. Will it be a problem for some kids? Yeah. And then maybe we just want to back off on those kids and say, well, let's just worry about centimeters and meters and kilometers and meters. I only have 2 things to think about there. Because these other ones are pretty uncommon. I mean, how many of those do I really need? I need to measure little things. Centimeters good for measuring little things. I need to measure medium-sized things like people. Meters great for medium-sized things. I need to measure big things like going on a trip, kilometers. I don't necessarily need all of those. So there's kind of trade-offs to either method. Knowing all of these in that order and then just jumping decimal places according to the chart. That's pretty cool. Wouldn't it be even cooler if you had that like as a study aid in front of you all the time when you had to change in the metric system? You just look at the chart and say, oh, I just need to jump 4 places, this way or that way. Like having a multiplication chart on your desk. That would be okay, wouldn't it?
Do they have the 7-year versions?
I've seen some of those little things you stick on the kids' desks that have those on them. It just kind of depends. Some of them have them, some of them don't. Some of them have all of these in there. And if you taught the kids to list, you know, if they're written that way, they tell you how to change the number just by looking. which is pretty cool. But again, it's good to know how to convert, but the bigger picture is let's just measure metric all the time and only use inches and feet out of desperation, or we're forced to for some other reason. But in the classroom, it's my opinion, we should just always measure in the metric system. We should talk about Celsius, we should measure in centimeters and meters, we should talk about liters and milliliters. Yes?
Do you know what grade they start with?
Off the top of my head, I can't remember right now. But you start using a ruler pretty early, so you just don't hand out the inch rulers, hand out the centimeter ones. There's stuff that have both on them. That's cool for you and me who are familiar with both. But for kids, let's just pick one and stick with it. Not use the one with both on it.
So what happens when you put all those kids in? So you drop them all those metric stuff and then they work with this regular stuff.
Oh, and like people complain, this kid can't read a fraction on a tape measure.
If they don't
They'll figure it out. You know, it's not that hard to get used to half an inch, quarter of an inch. It's harder than the metric system. And someday will change to match the rest of the world. The world is not going to change to match us.
No, they're not.
All right, so let's see. I've done almost everything I wanted to do in chapter 11. And so we're going to move on to something else. Some things we're going to come back to. We're still going to come back to measurement. And we still need to play with 3D shapes, which were referenced in this chapter, but barely. Did anyone have a chance to look at chapters 12, 13, or 14 and offer suggestions? Because otherwise I just get to pick what I want to do,
I figured.
which is going to be fun anyway.
So
We're going to jump into chapter 14 next. And I'm going to do a few things in chapter 14, and then as time permits, we'll jump back to 12 or 13.
yeah, I figured.
Okay. So,
Do it, Aaron wants to do.
okay. So next class, please dress comfortably because we're going to play the metric Olympics.
That means you guys all come on
You
Monday.
got to come on Monday, yeah, because I need people. And I'm going to have to try to
Can't just
figure out.
me and Gary doing the metric.
So I'll need to figure out a way to video record the metric Olympics for Debbie. So I'll figure that out, Debbie. I'll get a camera that works in this room. You know what's kind of cool? I can do Google Hangouts from my cell phone.
Yeah,
So I could just carry my cell phone around for class and just do the recording from there.